Hey everybody, thanks for tuning into the live stream. This is our first virtual meetup for NYC Data Council. We have two talks in plan for today. First is from Google, the second is from DeepNote, and we're going to talk about managed notebook environment. So without further ado, I'll introduce the first speaker, Jeff, to get us kicked off. And so for the first talk, we'll have two speakers, Jeff and Tim. Let me add them to the stream.
Hey. Thanks, Kira. And hey, Tim, how's it going? Thanks for joining, everyone. So first, we're going to talk a little bit about going beyond spreadsheets. And I'm Jeff Sternberg. I'm a technical director in a group called the Office of the CTO in Google Cloud. So I want to start off by mentioning an old friend of ours, spreadsheets, computerized spreadsheets, that is, that were introduced into the world in a little over 40 years ago. So this is an old technology. I think we know and love it well, but we've been trying to get away from it for a while as an industry or as knowledge workers. Here's an example in the Wall Street Journal from a few years ago where there was an article about CFOs wanting to move away from Excel and in an accounting process and try to use more centralized database systems and so forth. The reaction to that was readers said, you can have you'll have to pry Excel from our cold dead hands, right? So maybe not the easiest thing to transition away from, and I think there's probably a bunch of reasons for that. People love spreadsheets; they're super powerful, and they're really integrated into a lot of workflows. So there's a problem though, and if I do this interactively, I typically ask the audience, what does this number represent, right? So maybe Tim, you can substitute. What do you think this number represents?
I don't know. Maybe how much data something, how much an average spreadsheet, how much data an average spreadsheet holds.
Yes, exactly. This is the maximum number of rows in an Excel spreadsheet. So it seems like a big number. It's 1 million rows, but it's not enough, right? Problem two, not enough in a lot of situations. Let's put it that way. It's enough in many situations, but not enough in a lot. Problem two, quality, right? We've all probably seen spreadsheets and models and workbooks that have, a small error here and there. And there was actually a study published on this in 2016, and essentially errors are rare on a per cell basis, but one bottom line value is likely incorrect in any given analysis, right? Any given workbook, and moreover, those errors are hard to detect, and organizations are fairly overconfident in their accuracy of their spreadsheets, right? So QA is certainly an issue here. Another issue, sharing. So how do you share a spreadsheet? How do you tell a story with a spreadsheet? It can be difficult to do, right? We've probably all seen a spreadsheet that has sort of mixed numbers and summary descriptions, and sometimes you have to follow the chain of tabs through them, and it's sort of difficult. Oftentimes requires some amount of reverse engineering, and I think probably not straightforward. Another issue, analysis itself, right? It's difficult to do things like geospatial analysis in a spreadsheet. It's not as difficult to do it in other technologies, which we'll talk about in a bit. But the question, what are you not allowed to do, or are you not able to do with a spreadsheet-based analysis? So I think that there's a solution to these things, and that solution is code. And I think we can transition from code or from spreadsheets into code. And I think that probably the first thing that people react to when they hear this is, but wait, business people, right, can't code. And I would counter that by saying, well, actually, you probably are coding already. Excel itself has 478 functions built in. Things like VLOOKUP are common. There's a few on here that maybe even that I didn't know when I when I looked at this. So COOP days and IPMT. So IPMT returns the interest payment for a given period and for an investment based on periodic constant payments and a constant interest rate. So that's what's happening there. Plenty of pre-built functions, as you will, and I think spreadsheet developers know this, come to know this situation pretty well. So more on this, right? So let's just use a simple VLOOKUP to do that. I think on the surface, this maybe is not that simple, right? But what's trying to happen here is we're trying to calculate the bonus amount for a salesperson given their sales and market that they sell into, either the eastern region or the western region. And so you've probably seen lots of spreadsheets that have this kind of work on them, kind of analysis on them. So I think a better way is to go beyond VLOOKUP with something like Python. I think that this is an approach that most folks who can do VLOOKUPs or spreadsheet formulas can probably get their head around. Here, what we're doing is there's a very simple package structure where the company's HR department has a get bonus function that's defined, and then a sales manager is looping through his or her sales team and calculating the bonuses based on the information that's coming from that list. I think instituting this in a broad sense is certainly doable. And why is that? And I think it's because demographics are on our side here, right? The kids are coding. Most college graduates that are entering the workforce today into knowledge roles, I think, are probably have some amount of computer science work or some amount of quantitative classwork. The kids code, right? One issue that we're presented with, though, is that actually getting started with coding in a in a corporate setting or in a beginner setting can actually be pretty difficult, just based on installing the Python computation environment or doing the machine setup, right? And even this is a tweet from a data science professor talking about this, right? We're not talking about installing software in student computers, right? We're installing it. we're using the cloud for that. And so the way Google has thought about this is with an application called Colab or Collaboratory. And so if we look at something like Jupyter Notebook and combine it with the ease of use of Google Drive, we wound up with Colab, and that really is to just reduce friction, right? Reduce friction in the environment for analysis to get started with. And here's a quick timeline. Actually, I realized that Colab started a while ago, actually, and it's a pretty popular tool at Google. This is an internal meme, right? The Swiss Army knife of Colab, and I would say thousands of people in Google use this tool every day. And so, to sum up, there are a few issues. I mentioned 3 or 4 of them here with spreadsheets, and I think that we can move into data science tools like Jupyter Notebooks, like Colab, etc. And we'll hear about some of the ways that that this has been implemented at JP Morgan, and also when in other situations, right? And so maybe I'll pass it off next to Tim, and he can jump right in.
Thanks, Jeff. So I'm Tim. I work at JP Morgan, and I'm responsible for a large part of our what I'll call enterprise Jupyter deployment. So I want to take a quick overview of some of the parts here that as a technical person, I might have to, like the challenges that I might face or the things, I want to be thinking about as, from a technical standpoint, not necessarily from a business leader standpoint, to kind of make this product successful and increase the likelihood of reasonably competing and hopefully replacing Excel. So one obvious thing is hosting. I can double click on Excel on my desktop and it pops open. Any product that you want to make needs to be as simple as that. Business users, as Jeff said, nobody wants to worry about installing things. Nobody wants to worry about getting their environment set up. It needs to be already there. Sharing, in the same vein, it needs to be as easy as sending a spreadsheet in an email or in an instant message. Excel makes it super easy to do, data analysis, interactive data analysis, pivot tables, things like that. So, you want all the same features in your Jupyter environment. Publishing and reporting, obviously, Excel, we can export things to PDF, we can export things to various formats, PowerPoint and whatnot. Notebooks need to have these same features. Reproducibility and testing is one area where actually notebooks can exceed Excel because Excel doesn't really have great support for unit tests and things like that. So, convincing people that you can get rid of massive untested spreadsheets in favor of well-tested, reproducible notebooks is often very convincing, especially for regulators. And finally, and probably most importantly, education. It's not something that you can just give a cool tool to people and expect adoption to just follow. Everyone knows you need to be programming, but to really drive that into business, you need to be actively teaching. So this will be a quick overview. There's going to be more content in the slides than actually I'm going to talk about, but I think they're going to be reposted in some form, hopefully, so you'll be able to refer back to them. On the hosting side of things, the state of the art is open source, so it's a pretty great state for us. We don't have to worry too much about building out our own infrastructure. Plugging these libraries in is super easy, and there's lots of tutorials available online. I think there's a couple of great ones like Zero to Jupyter Hub, things like that. Cool. You have to be a little bit careful, especially if you have a little bit of a smaller business and you don't necessarily have as much infrastructure. And not to disparage any of the all-in-one hosted providers, but there's a lot of hosted Jupyter solutions right now. And one thing that in our experience has been something tricky to manage is, does every business user need a massive GPU instance for their Jupyter notebook? So, similar to the I don't want to have to worry about installing any libraries. You want to make sure that if you are going with an all-in-one hosted provider, that it satisfies your needs and your costs. But at the same vein, if you do have infrastructure already, getting these things set up to run on your existing infrastructure is pretty straightforward. Leveraging, so Jupyter's built on a couple of libraries underneath that are super extensible. So, don't worry about using a vanilla Jupyter install. You can customize kernels. Actually, the code here is a hook for customizing the default IPy kernel. Throwing in some telemetry, some metrics, resource limiting, stuff like that. Learning more what your users are doing and more importantly, what they're struggling with can really help you when it comes to the education side. And we do this, and it's extremely valuable for us to know what people are doing on our platform. There's a talk here by my manager, actually, from 3 years ago about managing Python at scale without breaking the bank. And this is in the same vein as that professor's tweet that Jeff shared. People don't want to worry about packages, and it's not even just getting Python installed and getting it set up. You go and upgrade one package and you break another package. People don't want to have to deal with that. So some of these things that might have been considered old-fashioned, things like monorepos or separating all of your business code from any of the dependencies it has underneath it, pinning versions of things, all of this stuff, from a developer, you might feel like, oh, this is kind of holding me back. I want to be able to install the latest and greatest things. But for a business user, they don't want to see an unintelligible error pop up when two packages conflict with each other. So this is a great reference about sort of how we do it and how we manage this. I think we've got 50 million lines of business logic and thousands of open source libraries. But this is something you definitely need to think about. Just giving people access to Jupyter notebooks with arbitrary kernels and giving them the ability to install random libraries is going to be a recipe for disaster when it comes to moving things to production. Oops. Cool. Sharing is kind of half solved. And the version control side of things, there's lots of extensions you can use. Jupyter Lab Git is one, but it's also integrated with vanilla Jupyter. Making it easy to connect to shared drives or remote file systems. Again, leveraging the extensibility of Jupyter makes these things easy. And for business users, they're constantly asking for things like, I want to be able to drag from a shared drive into wherever my kernel is sitting. There is some complexity when these things are moving on-prem, off-prem, and there's lots of things to think about. Like, do I need to strip data from notebooks because maybe there's some entitlements concerns? But all of this stuff is super easy to do and pretty well documented, given that everything is open source. I would be careful. I know this is, this might be a controversial slide to include here, but the real-time collaboration things and more generally, any of these big features that tend to pop up, and you see them especially with a lot of the all-in-one providers, really have to consider whether the disruption to your business users or the complexity that it's going to present to your business users, and potentially if you're dealing with permission data, things like this can become even more complicated. Let your priorities be driven by the users you're trying to get, rather than the cool, flashy new technologies that are popping up. This is probably, apart from education, the single most important thing. Excel, it's select a couple cells and click chart, right? And then if I want a different chart type, I click a different chart type. If I want, if I want to get a pivot table, I click on the pivot table button. You need to build technologies, or at least install the existing open source ones that make life equally easy. And this has been one of the main ways we've gotten business users to really buy in. Some things like streaming data, Excel starts to scale pretty poorly. Python's not going to have any problem with that. So I've linked a couple of the main open source libraries. Again, the state of the art is open source right now, so that's a great place to be. There's a video on the next one, which I don't think we really need to take time to watch because I don't want to take up too much time. But I basically go through, and I'm sure we can link to it later and show you. Actually, maybe we can just can you hit play for not the whole time, just a couple of, or maybe skip ahead 15 seconds, just so we can see some of the stuff that you want to do. So this is a tool that actually JP Morgan wrote, and it's one of the main tools that's been helping us, convince business users to use our product. And so basically, I take a data frame here. It's probably too small to actually see what's going on, but I'm able to construct a pivot table and the language, the column pivots and row pivots and values and filters and stuff like that is all what a Tableau user or what an Excel user would be familiar with. Being able to do what I call interactive cross-sectional data analysis is something that Excel is exceedingly good at. And so notebooks have lagged behind this a little bit. I mean, I don't want to disparage Matplotlib or anything like that because it's a fantastic library. But there's new and emerging tools to do this type of interactive thing that just, at the scale that you're able to do here, it's not a million cells. I could do a billion. There's an example on Medium that popped up today about analyzing a 1 billion row data set in Jupyter with Viex and Plotly. And that type of scale just isn't possible in Excel and arguably never will be. So publishing and reporting is a space that's really grown in the last year. And so again, with business users in the focus, there are always going to be users that aren't super comfortable, with code and with coding. So one area where we've been able to convince them of the importance and the sort of value of Jupyter without actually making them code is by working with some of the more, some of the developers, some of the quantitative researchers, and having them leverage notebooks, but having the end results be fundamentally notebooks underneath, but have the appearance of either a web app. So Voila lets you turn notebooks into web apps, or you can construct relatively sophisticated PDF reports, Word documents, even PowerPoint, though I'm still working on that library. So this is another area where even if you're not coding directly, notebooks value can exceed Excel greatly. Testing is the huge one. No more, fat finger errors with Excel. This is an area that is probably pretty new. We've tried to impose good practices about if you're writing a library, don't write your library in your notebook. And I know there's a really, I'll say controversial talk from a recent, actually from JupyterCon, that was something like, I hate Jupyter notebooks. And these are all valid arguments that you need to address, but there's tools that we're working on and tools that others are working on, as well as just best practices that you can establish for making sure that notebooks have essentially full test coverage. And this is something, business users, it's kind of mixed whether they care or not, but certainly everyone can appreciate that if you're generating a number, you know that it's well tested. If anything is going to break, especially in the world of packages moving underneath, you're going to pick that up before somebody opens the notebook or before somebody generates the report. And this is probably the most important one of all, is education. So setting up training programs to teach business users how to use Jupyter and Python. A lot of them are being told the same things, that they need to learn how to code. And a lot of them are CS majors or people who have done programming in the past. Setting up where we explain to them, okay, well, it's not enter to execute a cell, it's shift enter. Kind of teaching them the language of Jupyter, teaching them what notebooks are, showing them their value. This has been probably the single most impactful thing about driving adoption. So, initially it can be a bit of a time burden setting up one-on-one help, but certainly it pays dividends in the end. Building from the ground up, this is something that we found success with, but depending on your organization, it's going to vary. A lot of the more junior developers already have coding experiences. A lot of economics programs are requiring programming. So building from the ground up, and if a manager sees everybody on the trading floor running Jupyter, at a certain point it's gonna drive adoption into more senior levels. And in a lot of cases, that adoption is also being driven from the top down. And I always say this one because I think this is as a programmer, we kind of see these tools and we want to say, oh, Excel is bad, let's get rid of it. I think that Excel has its place. It has its limitations for sure. It also has its strong points. So teaching business users how to leverage the two together for maximum benefit. And there's great libraries like Excel Wings that let you, interact with Excel from Python. You can really get the best of both worlds. I think that's probably, yeah. So that's just a brief technical overview. Jeff, do you want to jump in?
Yeah, thanks, Tim. That was great. I actually learned a bunch of stuff there. So I think we may have had some questions come in. If not, then we could turn it over to Jakob. Kira, are you still around? Oh, we got one. Okay, so, oh, there you are. Hey, Kira. Great. Okay, so there's one question in the chat here. So if you were to start from scratch within an established corporation, what would your first steps be? So I can give my take on that, and probably Tim can weigh in. So I would say, start, like Tim said, with thinking about education. I think that's probably, if you kind of reverse the flow, at some point you're going to have to introduce, this idea of using notebooks across business teams or similar tools. So think about how you will integrate that, how you'll teach people, who are going to be your first sort of target customers, and what are their, what's their motivation. And do that before all the tech stuff, right? Because the tech stuff it's easy to get sunk into. What do you think, Tim? Is that?
Yeah, definitely. I think you will find, especially within an established organization, people that are interested in this already. And especially, you'll always find technical people who are interested in this, but especially on the business side, you will find people who are interested in this. So really getting to know them and the problems they need to solve, that's going to be your best kind of leg in. On the technical side, my only advice is don't do anything yourself, right? If you're in the type of organization where you can go and leverage a cloud provider, then do that. If you can't, then I'm sure you can get Anaconda or any open source distribution, and that'll get you off the ground. If you have a machine, you can run a multi-tenant Jupyter Hub instance on it. There are full guides in the documentation, and again, the state of the art is open source. Have some thoughts very briefly about data, because that always is where the hiccups come in. If I've got sensitive data in the output of a notebook, I need to kind of get ahead of audit and regulations prior to setting these things up. But certainly, if you focus on a business user and the immediate problems they're trying to solve, you'll have won a strong ally.
Yeah, totally, and that includes IT business, IT leaders as well, right? So one thing that can happen is we have another question here for thinking about this from a sort of a risk perspective in the IT organization. So I think having a process, a sort of a governance process or a working group, if you will, within the technical organization around thinking about going beyond spreadsheets and the ways that we can empower business folks in a collaborative way is super important. And certainly, things like data access, governance, authentication, access control, right? It's great to spin up a virtual machine in the cloud, but you want to make sure that only folks in your organization can access that machine, right? Probably want to look into disabling, root access on that shared Jupyter Hub instance, for example. Things like that, and it may seem like a bit of a lift to get those things started, but it's super important because you don't want to go into a situation where you've opened up a new risk or some sort of security issue has come out of your new project with this. Anything to add that I missed on that, Tim?
No, I would just say that Jupyter is really just the tool here, right? If I'm talking about data, right, the notebook is just the way by which I access that data. So I'm going to have libraries sitting underneath there. I might have to worry about, okay, if people are pulling data into my notebook instance, how am I dealing with that? But certainly the end of the game isn't the notebooks. But I would say that the notebooks themselves should introduce any additional risk concerns. They might unlock programming for people. This is something that sort of we are in constant conversation with. You might have people programming who maybe we don't want to program, and there's always a certain amount of risk of making key critical business decisions off of a notebook. The key thing to keep in mind is, in a notebook, you can establish best practices, you can do testing, you can push things into libraries. None of that you can do with Excel, and Excel is equally likely to be, have business decisions made off of it. So really, working with technical leaders, working with people who are in charge of risk, and keeping in mind what are those business concerns you want to do, you can pretty easily drive best practices across even large organizations.
Yeah, that's it's a fair point, right? What is our baseline that we're comparing against when we think about risk, right?
And this is something you see a lot where it's sort of if there's a new player, it might get held to different standards. The one great thing is Jupyter, in our experience, has been super flexible with being able to meet those higher standards. And so that's one of the reasons why. And when you show that, you can basically say, look, the risk of Jupyter is not greater. It's substantially less. It even it helps drive the migration off of Excel even further. There's a question here about IDEs versus Jupyter. And I think this is a really interesting one, especially for developers. But I just wanted to jump in early and say that line is getting increasingly blurred. There's a couple of great teams working on Jupyter and open source, and there's a project from a company called QuantStack that they've built in consultation with Two Sigma, which is a full Jupyter Lab debugger. So even those lines about IDE versus is a notebook a scratchpad, those are starting to blur. But it really is an organizational decision. We generally encourage, if you need to do hard development, that you should do that in the IDE, and that the notebook be this kind of scratchpad exploratory environment.
Yeah, +1 agreed on that. You're not going to develop full web applications in a Jupyter Lab environment, or if you do, more power to you. I think the notebooks are great for data analysis, exploration, all of the kind of slicing and dicing that you might do in data analysis. So I think that is the last question time. That's the last question we can take interactively. If you do want to follow up with questions, connect with either myself or Tim on our LinkedIn's or Twitters or GitHubs and the things, and we'll follow up from there. Thanks.
Thank you, Jeff and Tim. So our second speaker is from DeepNote, and I'm gonna try to do this.
Hey guys.
Let's see.
Cool. Can you guys hear me well? Cool. Let me share my screen real quick. I totally forgot about it. To do it beforehand. Let me just find it. It's a bit different. Just 1 second here. All right, here we go. Can you see my screen now? Perfect. So thanks a lot for having me. Thanks a lot, Tim and Jeff, for the talk. Let me tell you more about using notebooks as a team. Even though the title of the talk is about using notebooks as a team, I'm just going to be super upfront. Using notebooks in a team is very difficult. Simply, we are not there yet. So a huge part of this talk is going to be about the future, how it's going to look like, and what we see as how the collaboration is going to look like in a couple of months, maybe a couple of years, maybe a decade or so. Quick background on me: I'm Jakub. I spent a lot of time doing human-computer interaction research at many places. For example, University of Cambridge. I spent some time writing development tools at Mozilla Firefox. I was a CTO of a data analytics company, which is where I felt a lot of pain building data science tags and using notebooks. And lastly, I'm the founder of DeepNote. So what is DeepNote? The best way how to think about is DeepNote is a better data science notebook. Okay, so what makes it better? Bunch of things, but it's important to understand the way how DeepNote fits into the existing ecosystem. So first of all, it is fully Jupyter compatible. The existing ecosystem is pretty strong. There is no reason to reinvent the wheel here. The main benefit that DeepNote brings is the fact that it's fully managed with some advanced features that you might not see in other notebooks as of today. So what are those features? First, they are all about collaboration. We strongly believe in collaboration, and a subset of collaboration is real-time collaboration. It is a controversial topic for sure, but we are strong believers that this is a must-have, not for all use cases, but for some of the use cases that we are going to be talking about later in this talk. We help people with versioning, we help people with code reviews, and we make notebooks fully reproducible. There are some ways how you can do it right now, but let's be honest, the experience is just not there yet. And we are doing a lot of research into how we can improve our tooling to get us where we want to be. The second area of innovation really comes from the individual productivity. So we spend a lot of time thinking about how we can make individual data scientists more productive, whether it's by helping them to visualize their data frames, or it's by building better code intelligence, like refactoring tools or autocomplete, or just rethinking fundamentally how shortcuts work in a notebook. Cool. One last thing that's worth mentioning is the fact that DeepNote is fully compatible with the existing ecosystem and really plays well with other tools. So with that being said, I think that's pretty much it. What I want to say about DeepNote. And now let's dive into the talk itself. So this is going to be split into two parts. As I mentioned at the beginning, the collaboration right now is in a pretty bad state. So we're going to be talking a lot about the future of collaboration, and then we will talk about how we can prepare for that kind of future. There are some things that we can already do right now that's going to give us amazing results when working in a team. So we should do that. Cool. If we are going to predict the future, turns out, well, we are always going to be wrong in some aspect. But turns out that we can actually do a pretty good job predicting the future when it comes to the trajectory of notebooks. When we look at the past, we quickly realize that spreadsheets is a really good analogy to what we are experiencing right now with this new medium of notebooks. They went through for a pretty long history of changes. Some of them were some small minor changes. Some of them just like radically brought new ideas. So who are the users of the notebooks? If we want to talk about collaboration, we have to really understand the personas behind them. For example, as I mentioned at the beginning, real-time collaboration as itself is quite a controversial topic. That partly comes from the fact that there is no clear understanding of who are the users. Some people might benefit from real-time collaboration. Some people won't. So who are the users? First of all, notebooks have very wide range. It's like a wide spectrum of users. On the one hand, we are talking about data scientists or analysts, people who are training models, people who are exploring data, who are building visualizations, while on the other end of the spectrum, we talk about data engineers or DevOps or even IT, people who are more concerned about deploying models, about monitoring, about maintaining data pipelines. And this is going to be very different how these two personas collaborate, not just within their own persona, but also between. This might seem kind of complicated, but we are not even we haven't even started. The second kind of distinction we have to understand is the level of proficiency. Some people, especially on the beginning level, like on the beginner level, are going to need simply more handholding when it comes to building models or producing reports. As soon as we get to more advanced state, the shape and nature of collaboration is going to shape more towards reproducibility, versioning, and so on. So we really have to consider all the skill set of all the users, how proficient they are with Git. Do they know how to manage clusters? Do they how good they are at writing Python? It's so easy to write just ugly Python that's not going to be reproducible, no matter how much we try. How well they understand integrations, for example. As you may know, getting a beginner to connect to Postgres in Python is still going to be pretty difficult thing to do. And we don't even talk about how to write some commands into Unix terminal. So now that we understand the whole spectrum of users of notebooks, we have to understand how they collaborate. Right now, as I mentioned, the collaboration is in a very nascent form. Right now, we are trying to figure out a way how we can efficiently collaborate within, for example, analysts. And then the next step about it is to just figure out how can we collaborate from data analysis, from a data analyst all the way to data engineer or someone who is going to be deploying the model. The last thing that people want is just like receiving like a really ugly Jupyter-based model, and then trying to figure out, okay, how was this created? Where are the dependencies? If I'm going to put it into production, how that's going to work? Even though this is already quite difficult, we are not even talking about something that we call second-order users. Those are essentially people who are outside of the data science organization, primarily, for example, people from marketing or managers or clients, people from legal, or like people who are making product decisions. So the collaboration between these groups might seem pretty crazy. I mean, at the end of the day, like, we are having trouble figuring out how to make notebooks reproducible, but it is something that's ahead of us and something that we have to think about. Now, turns out that some of these things are going to cause pain, no matter what. IPyNB as a format is extremely versatile format, and we can find a way how to make it work, but it's not going to be pretty right from start. We can take, for example, spreadsheets as an way how to think about, because it's a good analogy. Back in the day, like when spreadsheets first came out, it was a pretty big thing, but you still needed to find a way, like, to find the right hardware. You need to find the right software. You needed to figure out a way how to send your spreadsheet to someone else. In many ways, we are actually back where we started. Again, we need to find a way how to unify the environment in which the notebooks are running, in the sense, what kind of GPUs are using, what kind of technical stack you're running on. Then the software layer, like, are you running on Mac, on Linux, or what kind of libraries, what kind of dependencies are you using? And then lastly, where are you taking the data from? If I build a model that's reading a CSV file from a local disk, it's just simply not going to be reproducible no matter what. These are big problems, but fortunately, like, we've seen the past. We've seen how spreadsheets move from floppy disks to Google Sheets, where everything is essentially taken care of, fully managed, and we think of collaboration as a second nature. So the next step in understanding the future is understanding what the notebooks are and how they are different from what they have already seen in the past. Notebooks are fundamentally a new medium. They are more powerful than anything else that came before it, and as a result, right now, frankly, it's a wild west. It's going to take us some time for us to figure out the right patterns, the right best practices, and we also have to brace for a couple of years where some of the features are simply going to be pain. Cool. So what can we do right now? I painted a pretty horrific picture of the current state of collaboration in the notebooks. However, it is really something that we should look forward, because this is going to improve quite a lot. If you feel a pain right now, like, you can rest assured that in a couple of months or a couple of years, this pain is going to go away, and suddenly you will have a much better system. So even the early investment right now into notebooks is going to just get better over time, and you're just going to get benefits essentially for free. So how do we collaborate in team right now with what we have? First, there are some principles that we should follow no matter what. Whether we are doing exploratory programming, just like trying to produce a report or visualization, maybe some throwaway code, we should always follow these 5 principles. First, there should be an easy way how to use notebooks in your organization. You really need a place where you can just write code within seconds. A lot of people are currently in a stage where they set up Jupyter on their own machine and found a pretty good way how to do this efficiently. Just open up a terminal, write a bunch of commands, and suddenly you are up and running. However, this is not a good practice, and it's going to be a huge bottleneck as the team and company grows. So this is just a must-have. You need to figure out a way how to find a unified environment. And well, if you do this in a cloud, that's going to be so much easier for you. Essentially, all these things that I was just talking about, you'll get for free. Whether you are going to use SageMaker or Google AI Platform, or you're going to deploy your own Jupyter app, this is a step in the right direction. Second, all notebooks should be easy to modify and remix. So when someone shares a notebook with you, right now they are mostly in a read-only form. Most people really just like go back to sending good old screenshots of their outputs. But again, this is a bad practice. There is no good solution for this right now. Really, like Jupyter as the most popular notebook today doesn't really have very good user interface for people who are not data scientists. So it's kind of a stretch to imagine that I'm going to send my notebook to my manager who doesn't know how to write code, and then somehow be able to modify or remix the notebook. But imagine what we have seen. Just like look at what we have seen with spreadsheets. These became quite an universal standard where I can send a spreadsheet to pretty much anyone in the world, and they will be able to take that code, take the table, that is the whole sheet, and then produce their own results, do their own analysis, and do that kind of like last mile analysis themselves. The first thing that we have to think about as soon as we allow people to make changes is a robust way how to version control your code and how to track changes. There are some pretty good existing extensions to the interfaces that we are familiar with. Tools like NBDime or Git integration into Jupyter Lab are going to give you a lot of options how to make sure that someone's not going to just go in and delete your code that was actually very important and you will need it later. Fourth, we have to figure out a good way how to list the requirements of each project. We need to think about notebooks as something that's fully reproducible. So there are good ways how to like good rules of thumb. For example, never use your local files. Simple as that. If you're running on a cloud environment, that's going to be so much easier because you just can't do this in a way. You have to upload that file, and it's going to stay there for anyone to reuse later. The second good practice is just follow the general Python best practices. Always list the packages that you are using. Requirements.txt is a great place to do that. You should always follow this no matter what kind of code you are writing. The last thing that is this is a best practice, but unfortunately there is no a good way how to do it right now is to leave feedback in place. So imagine receiving your spreadsheet from someone in your organization. It is very easy to close that feedback loop and point out to a specific cell and say like, hey, I think there is a mistake, and leave a suggestion how to fix this. This was a huge difference when spreadsheets did not have this, and it was a huge bottleneck for growth within organizations. As soon as we got those features, things started to look pretty well for spreadsheets in orgs. Now, all these 5 things you should follow at all times. I know some of these are more difficult than others. There might not be good ways how to do it right now, but you should still invest time into figuring out how to solve this, because it's going to be well worth it. There's a second set of good practices which you should still follow, but if you are just writing exploratory code, I mean, it's fine. As soon as you are writing code that is going to get into production one way or the other, you should always follow these 5 other things. First, follow established software development practices. When you are writing notebooks that are going to end up in production, I mean, there is no difference between ugly notebook and production level code. You just have to follow the same guides. You have to write documentation. You have to write tests. There's unfortunately no other way how to go about this. Fortunately, notebooks make it much easier for you to include some documentation. So that's going to help out there. If you're creating models, just log all experiments automatically. There are really good tools out there, really good companies out there that made great solutions on how to track all the models that you're working on, and you should definitely implement that. The third thing that you should never forget about is to split development and production environments. I know it's kind of difficult to do that, but it is well worth it. And in many industries, you don't really have a choice. You need to figure out the way how to sanitize user data and create a new environment for your data scientists where they have full access to the data while keeping all the sensitive stuff on servers somewhere else, so that you don't run into any security or compliance issues. Fourth thing that's quite interesting, good practice is to parameterize your notebooks. This might sound pretty difficult to do, but it's actually super simple. Just put all your variables, all your inputs at the top of the notebook, so that when someone else comes in, they know the first 5 lines, like that's all they need to change. They don't need to like go through all the 500 lines of code to find the variable they have to change. This also makes it easy for including notebooks into all the data pipelines. So for example, let's say that you want to automate your notebook, want to run it every single Monday at 9 a.m. There are good tools like Papermill that's going to just take that raw notebook and do it for you and just switch up some of the variables. Lastly, if you're writing production code, think about continuous integration. As soon as you make a change, there should be some kind of test suite that runs that makes sure that nothing breaks. Notebooks are notoriously very easy to break. You might just forget to include some dependency, or you might run multiple cells like out of order, or you might accidentally delete something. That is going to be a huge problem later down the road. Continuous integration is here to help. Cool. And I think that's pretty much it for some of the best practices for using notebooks in a team. I'm going to leave this open to questions. I know we have only a couple of minutes left, so let me just switch back to this other interface. Jeff or Kira, can you actually tell me how to read the comments if there are any?
I think there's maybe one question that came in earlier. Can you see the comments?
Yeah, I can see the comments. Oh, that's actually a good question. So the question is, how does speed of accessing S3 buckets or Google Cloud Storage in Deep Node compare to doing it on a local machine? Really, the answer is it depends. Usually, you would want to set up your cloud environment in the same zone, in the same region as the rest of your infrastructure. So, for example, if you're already hosting everything in Oregon, then you want to set up your data center infrastructure over there as well, and then it's going to be super fast, much faster than on your laptop. I mean, at the end of the day, if you're going to work with a 500 gigabyte data set, there is no good way how to fit it in your laptop in the first place. So it's going to be super fast. When it comes to Deep Node specifically, this is something that we are working on still. We are deployed only in one region, which I believe is the East Coast. So that's going to be super fast. We made quite a lot of optimizations to make it as fast as possible. But over time, we have a couple of things that we also want to deploy that's just going to make it really feel like a native speed. Cool. If there are no other questions, thanks a lot. I know that we have only a couple minutes left, so I'm just going to hand it back to Kira.
Yeah. So yeah, thank you so much for our speakers. This is our first virtual event, and thank you for listening in. If you have additional questions, feel free to email to me. I put the email in the chat, or reach out to us on the Meetup page. Yeah, but thank you again. We will post the recording afterwards. Yeah.